Hello, everybody. So welcome to another talk from DebConf. So Andrej Shadura will present Building Debian System Images in Minutes with Debos, which is a presentation from Andrew and Anna. And good luck.
Thank you. Welcome to this talk about building images with Debos. The second name of Anna, also Debian developer, is on this slide because it is heavily based on the presentation she did. Oh, what's that? She did at ALC last year when she worked for Collabora, and specifically she worked on Debos. This talk has some updates on basically since then, and but basically she contributed a lot to this talk. I don't know, it's a bit slow. Right, so let's say you want an image of a Debian system. Why you would need this? I don't know. What's going on? It's switching back and forth. Is it right? So, right. So, you want an image of a Debian system. Why you would need this is a long question, and Riku Voipio answered this question really well in his DebConf 15 talk, where he made an overview of different image building tools for Debian. But basically, the short version is that people want to be able to deploy the operating system fast. In this case, Debian-based operating system, or Debian. And if you use Debian installer, which you obviously can produce images, and you can script it with preseed and all that, according to Rico, it takes about 14 minutes to install Debian from scratch. And this process is not necessarily reproducible because it depends on lots of things like, well, if you're installing using NetInst, it depends on your network connection, or it depends on your installation media and all that. So it's not necessarily reproducible. And then if you have a ready image pre-built, copying it to an SD card or something, it makes it a matter of seconds, especially if you use Beamup tool and not DD. Beamup tool is a really cool thing which actually writes only parts of image which are necessary and doesn't write all of the emptiness which DD doesn't know how to do. So our use case, some interesting glitches. I haven't seen this before. So our use case for building images is Apertis. It's a Debian derivative. What's wrong? I don't know. I haven't used this PDF presenter tool for a while, and it's just having those glitches. Yeah, so Apertis is a Debian derivative for use in automotive industry. So basically, originally it was intended for infotainment system in cars, like doing navigation and radio, all that. These days, it's more for embedded uses inside the car, but still the purpose is more or less the same. Apertis targets a lot of devices running different platforms. Most notably, it's ARM64 and ARM HF. But there are also boards with AMD64 compatible processors. So we've got lots of images for different devices we want to build. And also, there are AMD64-based images, which users normally run in virtual machines like VirtualBox, which come with all sorts of SDK. But basically, there's an IDE, all tools they need to develop applications for Apertis. And our original approach to building images was to use Linaro image tools. They had lots of downsides. Most important of them was they were really complex, written mostly in Bash. They were difficult to debug, and they relied on kernel mechanisms like loop devices, which, as it turned out, they were not always reliable, and we often had issues that loop devices would not mount properly, and it would be only solved by completely rebooting the work on which the image was built. So we were, like lots of people on this project were frustrated with that process, and at some point a new tool was created, mostly developed by Short Simmons, another Debian developer. Because we were basically looking for tools to replace what we were using before, and none of the alternatives did what we wanted to do, or what Short in this case wanted to do. So there was VM debootstrap already deprecated by that point, VMDB, which Lars Vesenius was developing back then, but it was not yet ready for use, for general use at that point. Obviously Phi, but Phi is a bit too complex, and I don't remember exactly why it was not taken, but I guess the complexity was a bit one of the reasons. Short has developed this tool, which is modular, and basically it creates the image by executing a sequence of simple atomic steps. Not atomic, but like basically atomic for the purpose of this tool. It doesn't need root, usually. You basically, what's wrong with this rendering? You don't need root. You basically want to have KVM available for your user, but you don't need to have proper root privileges. But also this can be worked around. Right, it is designed to be easy to integrate with CI systems, and the recipe is a YAML file which is pre-processed through the Debos is written in Go, and basically it uses the text templating engine of Go. And obviously it is made primarily for Debian, but if you want to run it on non-Debian systems, you can run it in Docker. It supports basically any architecture supported by Debian and QMO. And well, we've tested it and ran it on a bunch of different architectures. You can see them on the slide, no need to read, basically. But the interesting thing about how it works internally is that it uses a library called fake machine, which sets up a QMO virtual machine using the /user from the host system. And then inside of that virtual machine, we already have root. So we can do funny things like creating loop devices and all that without having root outside. It also uses QMO in user mode to do debootstrap and all of those things inside of the virtual machine to run foreign architectures binaries. And this is basically what makes it different from other tools, because, like compared to linear image tools, for example, it doesn't depend on the host system's kernel features like loop devices, because it runs its own kernel inside of the virtual machine. So even if it crashes at some point, for example, we could just tear it down and start it from scratch. And so we're not touching those delicate bits of the host's kernel. Well, Debos is not a build system, and it's not a replacement for a Debian installer. So you're not supposed to really use it to just install Debian from scratch, even though you can, but it's not supposed to replace it at any point. So in Apertis, we use Debos in a way that we run it as a part of a nightly build process. We get current binaries, current versions of the packages we have in Apertis, which is basically there's a Jenkins instance which runs Debos en masse and generates all of the target images we want, SDK images, and also there are special jobs to generate Docker images, which are used later to generate proper images. So we actually use Debos to, well, we cannot, so people using Debian in Docker, for example, they can just pull official Debian images from the Docker registry. In our case, we have our own registry, and the images we upload there, we create them also with Debos, because Debos has those, it can run debootstrap and all of those other tools. It can create exactly what we want. We create the root file system, upload it to the Debian, to the Docker registry, and we use it later to build images of the parses itself. But okay, it may look or sound a bit confusing because a lot of stuff in the short number of slides. Now examples will make it more clear. But oh yeah, before the examples, another example of using kernel CI, using Debos is kernel CI project, which is a kernel testing infrastructure. It builds a bunch of branches of the Linux kernel upstream. Builds them for it builds kernels targeting different devices and runs the kernel on the devices and up on the boot it runs a set of tests so that we can detect failures or regressions very early. So images, root file systems for kernel CI are also built using Debos. And there's also some more projects using Debos already. So now examples. Recipes look like that, basically. So you define the architecture and you specify a list of actions. One of them is, for example, debootstrap pack. And this, I will go into that a bit more further. So when you run Debos, as you can see, it runs debootstrap, in this case, and creates a root file system. There's only basically, if you go back, you see there's only basically two actions, debootstrap and pack. So we create a rootfs tarball, and that's what's happening. So everything after running Debos, blah, blah, it is happening inside of the virtual machine, which fake machine creates. So those recipes, they can be parameterized. So you can use the ghost templates and variables inside of this YAML file, and you can pass the values for those variables on the command line of Debos, like that, for example. So you can use the same recipe to build different images of different releases of Debian or for different architectures, like that. So this is an example of how to use the parameters. You don't have to declare the parameters on the top of the file, but if you want to provide same defaults, you can do it like that. And then you can just use them. The templating language is very similar to Ginger 2, or the Ruby on Rails similar templating language. I think it's called Liquid. But this is specifically the version used by Go. It's slightly more simplistic than Ginger 2. It doesn't have as many features, but it allows some really cool things like, formatting the image name or like providing default values. You can have conditional bits which only get run for specific types of images, for example, like in this case. You can basically the thing is the pre-processing happens before the YAML file is parsed, so you don't have to follow the strict YAML rules before in this file. So it has to generate after the pre-processing. It has to be a valid YAML file, but basically you can embed any of the templating instructions in it. So in Debos there are currently 12 different actions. So we used 2 of actions in the example we had before. So debootstrap, in case someone doesn't know what it is, it's a tool which there was a talk by Hideki Amane a couple of hours ago, a tool which creates a root root file system of Debian, given a list of packages. Basically, downloads the base system and any packages you want on top of it, extracts them without actually having the package or apt inside of the root file of this root. And you can also obviously run it on a non-Debian system because it doesn't require the package or apt. So Debos can run debootstrap to, I don't understand what's happening. So it can run debootstrap to generate the root file system. Afterwards, when apt is already inside of the image, you can use apt action to install a set of packages on top of what you have just created. So you can ask apt not to install recommended packages, only install what you actually request. So you can have it like that. So you first create a root file system for, in this case, stretch. You include 3 components: main, contrib, and non-free, and only install the basic minimal set of packages. And then you add like firmware and sudo and all of that on top of that. It's a very simple recipe. You can download random files from internet during the build process. You can also ask Debos to unpack it. Unpacking doesn't actually install file anywhere inside the image. It just unpacks it to the working directory of Debos. And then, using overlay action, you can actually put that file somewhere, or the directory somewhere inside the image. So if you look at this example, you see there's a parameter called name. So everything you download is given a name, and you can use this name to reference what's been downloaded in the overlay action. So it just basically copies what we have previously downloaded into the destination directory or to the root of the file system. Like that, basically. You can have a bunch of files coming with your recipe, and they will be put inside of the image. So you see, we've downloaded a firmware, we've unpacked it, and we also have a directory called overlays auto-login, and there's something we also want to put into the image, and it goes there. You don't have to specify the name or something. Right, so you can also run arbitrary commands inside of the file system you're building. It's as simple as that, basically. There are a number of variables you can use with that, and it looks like that. So you can copy files from the directory where the recipe is located inside of the image, and we can run the package, and you can run basically any commands you like inside of root or outside of it, basically. Another example, setting host name, and inside of the image. More actions to set up image partitions and file systems. This is one of the things where Linaro image tools didn't work well for us because they would use loop devices for this purpose. And after we've built a dozen of images, something would get stuck in the Linux kernel, and loop devices would not get unmounted, and we would have really strange errors. In this case, none of that is happening because it's all in the virtual machine. After we've created the image and we've partitioned it and created all file systems, we've done, and we destroy the virtual machine, and none of the state is preserved. Only the image is what we have as the outcome. So Debos works around the issues with loop devices very nicely. And that's an example. We basically create a number of partitions, and we tell Debos where to mount them, and which means you don't have to manually split stuff into partitions. You just specify it in the recipe. and you just install files wherever you like, and they will be automatically placed in the partitions because they are actually mounted inside of the virtual machine. There's another example made by Anna, which is a bootable image for Raspberry Pi, third version B+. You can see it on her GitHub. And Debos is being developed basically driven by the needs of the project, more or less, and like this project and other projects where we use Debos. So there's no specific roadmap or plan. We just, as we have the need to implement some action or some new feature, we just do it. So obviously, we accept contributions. So if you use Debos and it doesn't work for you the way you would like to, and you have a patch, you're welcome to help. Also, there's a to-do file where we maintain a list of things which we would actually love to have in Debos ourselves, but we don't have enough time. We welcome contributions, be it code or documentation or anything, literally. So if you want to know more, there is a bit of documentation published at GoDoc. The code itself is at GitHub, the GoDebos, and also there's a bunch of examples of how to use it also at GitHub in a separate repository. So you can have a look and, well, ask me or other people who worked with Debos if you got any questions. So thank you for listening. I'm sorry for a bit of technical stuff I had with the presentation. So any questions?
Hi. Recently enough, I've stepped into an alternative re-implementation of the bootstrap, which is called debootstrap, if I remember correctly. It uses APT internally. It's more able to resolve complex dependencies, and it's generally faster, even though less universal. My question is, can we replace the implementation of the bootstrap for Debos and use debootstrap? And perhaps, is it supported now?
Well, it is not supported at this moment, but does wait, can you stay the microphone? Does debootstrap have the same command line interface as debootstrap, or is it different?
Well, from a user's point of view, it's mostly the same, as I can remember. But I'm not sure whether it's a drop-in replacement, especially when it comes to some exotic options that I don't use daily.
Well, obviously, if someone writes a patch to support debootstrap, I think we should be fine with accepting it. Just debootstrap it works, it does what we want from it, so we didn't look for alternatives really. But yeah, I mean, if you prefer debootstrap, we submit a patch and we'll have a look.
Thank you.
From debootstrap point of view, it's faster than the last release, the stretch. So please try to the newest debootstrap and please the difference between debootstrap and debootstrap. I want to know the difference. Debootstrap author says it's fast, but I'm not sure how fast it is.
So some weeks ago I did tests with the newer version of debootstrap and strap, and debstrap is a little bit faster. Maybe it's a factor of 1.8, but in absolute numbers it's like 15 seconds or like 20 seconds to 50 seconds.
Right.
So it's not that much currently.
Yeah, I mean...
just as a comment, one question, you said you can build images just in a few minutes and it's very fast. Do you have any numbers for certain images you build?
I don't have numbers right now. I can look up after the presentation. We just can go to the Jenkins and see how long does it really take to build an image.
So you said this BMap tool makes things much faster?
Well, it's a different issue. So BMap tool is a tool which puts an image onto the actual device. So I mean, it was just an example compared to, it was a reason why people would like to build images. So I mean, because there like some people want to say, why not just use a Debian installer to create images? Yeah, sure we can build images with Debian installer each time, but it takes at least 14 minutes, according to Riku, to create an image using Debian installer. And when you would need to do this like lots of times, basically from scratch, if you want to install it on a new device. Yeah, this way you do it just once. You create an image and you just write it with BMap tool, like matter of seconds.
So the speed of BMap tool can be used for every other tool that just
obviously it was not something as a benefit of Debos, even though Debos supports BMap, but it was just like why people would like to have images, because some other people might say, okay, I never used an image in my life. I just run the installer each time I want to deploy a new device. Yeah, which is a reasonable way to do it, but like it's not the best for lots of purposes.
One additional question, you had, for example, when you're using this apt action, you can say if the recommend packages will be installed or not.
Yeah.
Are there more options, or is recommend for the apt action the only one that's implemented? And how easy is it to extend if I want to add other options to the apt action?
Well, it is relatively easy to extend. It's I'm not really a Go developer. I've never written a single line of Go code except like fixing basically a couple of things. But it looks really readable.
So I have to know Go to extend it, and not only with some YAML things.
Yeah, I mean, I don't quite remember. I don't. Maybe. I haven't looked at the man page for a long time, but maybe there is some way to add extra options. I don't remember really, but to be honest, I only once had a need to extend those actions, basically. So it's general purpose enough at the moment. I mean, it implements most of the things you might need, basically, at this time.
Okay.
So, but it's easy to extend because, like, as I said, it is Go, but it's written. There's not much basically there. So it's like each action is in its own file, and it's quite readable. So it's just a matter of like 15 minutes, maybe, if you want to add something there. It's like not difficult.
Okay, but I have to know Go, and I think compared to other tools that are just written in Bash, it may be easier to extend those tools because it's only Bash instead of, there's a tool written in Go and...
Well, your mileage may vary, but my experience is that tools written in Bash of that complexity, they become unmaintainable, and if, like, my experience with linear image tools, I needed to fix a small issue with them, and I'm not sure I fixed that issue because it was so many layers of Bash. Basically, they had some sort of inheritance done in Bash, and it so the fact that it was written in Bash didn't make it easier to do, but on the contrary, it was much more difficult to modify compared to this, because this is well, Go is, for scripts, it's maybe not the best language, but for something bigger, it's much easier to read than if you wrote the same thing in Bash.
Okay.
One more question. If you have a custom Debian-based repository, a custom Debian derivative system, how is it easy to use Debos for that kind of system? That is, it will be another set of GPG keys, another debootstrap initial script.
Yeah. That's exactly what we do with Apertis, because this tool was primarily developed when we wanted to build system images for Apertis. So yeah, we have different set of packages, different PGP keys, different everything. And so this tool was developed with that in mind. So you can specify different, well, different location of a key ring, different location of other things, different set of repositories, and you can even ask it to not verify PGP keys if you really want to, but like it's not really a good idea, as you know. So yeah, that was the design decision to support that from the very beginning. So yes, you can use it with the derivatives of Debian.
Hi. What happens if the action breaks?
What do you mean breaks?
Fail.
Well, then build process is going to fail, unless you've developed a way to, work it around. But like, yeah, if the action fails, it fails.
And we cannot continue.
Well, if you have integrated Debos in your continuous integration system, you most likely want it to fail if it fails, and because there's something for other people to fix. So arguably, I don't know why you would want to somehow prevent that from happening.
Okay, thank you.
Okay, if there are no more questions, then I guess we can wrap it up. Obrigado. Thank you.